All right, good morning, 8th grade. We're going to continue some video reference, expanding our knowledge of exponent rules and the properties and simplifying them. So in the next part, we're going to continue our rules with some dealing with coefficients, okay? So coefficient are the constants being multiplied or divided. So multiply or divide the coefficients like normal, and then use the product or quotient rules that we learned last week with the variables with the same base. So for example, let's go through these here. So I'll highlight so coefficients yellow. Okay. So that normally means right there, that means multiplication. So 2 times 3 would just be 6. But then if I highlight in pink the variables, this is where I'm going to be using my exponent rule. So we learned that last week. If you have the same bases and they're being multiplied, you just do what to the exponents? Add them or subtract them or divide them or multiply them. Yeah, you just add them. So this would be x to the 7th. Okay, same thing here, coefficients. 6 divided by 2, last time I checked, that's equal to 3. But then if we look at the variable terms here, let me zoom in so you can see this better. Look at the variable terms here. That is the quotient rule. So with that a to the 7th and a to the 5th, am I going to add or subtract? Hopefully you remembered you subtract, so you're left with a to the 2nd. Going on to the next one, same thing. I'll go a little quicker. Coefficients, 5 divided by 10 is 1/2. So I'm just going to write that, 1/2. And then I will write here, I'll use my variables, 6 divided by 1, or b to the 6 over b to the 1. I'm going to assume 1 there is b to the 5th. So I'll leave that at the top. I'll just write b to the 5th up here. Then I'm going to subtract. But technically, you don't need that assumed 1, so I'm going to erase that. So in the end, I'm going to really just write this as b to the 5th over 2 for that one. And then this one, it kind of like jumps into this. Like, this is an important part because we did the power to a power when we looked at He-Man and all that stuff. But when you do power to a power with 2 products on the inside, you're really distributing that power of 3 to both numbers in there. So really that's 2 to the 3rd times x to the 3rd power to a power is just 3 times 3, which is 9. So now, so if I keep the highlighting the same, in pink, I dealt with it using exponent rules. But in yellow, my coefficient, I'm just going to use what it tells me to do. 2 to the 3rd power is 2 times 2 times 2, which is 8. So my final answer would be 8x to the 9th. Okay, cool. Next rule we're going to add to our repertoire, our toolbox, if you will, is negative exponents. Oof, I love this rule. It's really confusing at first for people to get, but it works. So here goes. So, okay. So basically, if you use the quotient rule and subtract the exponents, 2 minus 5, whoa, 2 minus 5 is negative 3. We want to simplify so there's no negative exponents. So if you express this visually to the way it looks like this way, 1, 2, 3, 4, 5, 1, 2. So really, it stays at the bottom. If you want to keep that positive, it's really 1 over x to the 3rd. So that's the trick right there, guys. If you are left with a negative exponent, it's called cross the line, change the sign. It comes down to the bottom and becomes positive if you want to rewrite it. Let's write that. So let me show you this in one of my favorite, and I showed this a little bit before. So my favorite part of this video on exponent rules. Let me go here. Make this a little bigger so you can see it. Where was it? Flip it over the line and change the sign. So, aha, here it is. Ah, sorry, messed it up. Okay, so there's a negative exponent. So we just saw that x to the negative 3 became 1 over x to the positive 3. So watch this. But I get rid of it. So you see how that flips and becomes positive? Flip it again. One more time. So cool. And then you can simplify it to 1/8. So that's basically the rule there. So let's go back to our video reference, our reference notes here, and continue going with this. So therefore, well, we did that part. Let's do another example here. So a to the 6th over a to the 7th. You use the quotient rule and subtract again. And you're left with a to the negative 6 minus 7 is 1, negative 1. So I'll just skip the whole visually part. Weird, right? Therefore, a to the negative 1, cross the line, flip the bar and flip it over the line. Yes, that's the way. However, that lyric would make this come down. So there's always like an assumed 1 there. So really, we're just flipping it and bringing it down to the bottom, making a positive 1 over 1, which is just 1 over a, like that. So what's the rule? The rule is simple. When you have negative exponent, flip over line and make positive. So one of the things that's interesting about this rule that this page hasn't shown an example yet, that means if they give you, for example, right, if it's at the bottom, it will come up to the top. So say you had like 1 over x to the negative 8, right? That same rule applies. We don't like negative exponents, so you flip it over the line and change the sign. So this would really come up to the top like that, or just x to the 8 positive. So it's an interesting rule. It's a little complicated. What it really just boils down to is that when you visually write it all out, really it's at the bottom. Yeah, or it really is flipping the line and changing the sign. So again, we'll practice that as we get going. So then the last rule, or one of the last rules we'll look at, is the zero exponent rule. This is the craziest thing ever. So so here's your example: y to the 4th over y to the 4th. If you use the quotient rule and you subtract, you're left with y to the 4 minus 4 is 0. So visually, this is where it gets weird. 1, 2, 3, 4 over 1, 2, 3, 4. You're left with nothing except for the assumed 1s. So really, you're just left with 1 over 1, which is 1. So therefore, y to the 0 equals 1. And that is true for anything, really. If I did this next one and I end up getting c to the 0, it's going to equal 1. If I show you here, let me go to a blank tab and I go here and I go online. Where's my calculator? I think I have this calculator. I use this one all the time, the scientific one. So if I put anything to the power of, let me zoom in a little bit, anything to the power of 0, it's going to be 1. So say I put 88 and let me raise that, not squared. I want to I change that to a 0. So if I put that to the 0, the answer is 1. So you can see I could put -5. Oh wait, yeah, well that would be -1. But if I put 99 raised to 0, it's 1. If I put x, well, it won't let me do x to the 0, but trust me, it's 1. Anything to the power, what's today's date? Today's the 26th. 26 to the 0, it's always 1. We had a big debate last week, or in the beginning of the year with compacted math. What's 0 raised to 0? It's also 1, but some people will debate that back and forth. What is 0 raised to the power of 0? So this actually comes up in the video here, way in the beginning.
To have some fun, if you raise it to a 0, then the answer is 1. Raise it to a 0, then the answer is 1. Have some fun, if you raise it to a 0, then the answer is 1. Have some fun, if you raise it to a 0, then the answer is 1. Have some fun, if you raise it to a 0, have
Look at that, that's cool. Sorry.
Have some fun if you raise it to now to have some fun if you raise it to a 0, then the answer is 1.
So no matter what, we raise it to the power of 0, the answer is 1. So now kind of recapping our rules here in our video reference, here. So we pretty much did all the rules, so I'll go through them with you. If you're multiplying with the same bases, you just add them. If you're dividing with the same bases, you just subtract the exponents. Power to a power, you multiply the exponents. This is the one I was showing you earlier. If you have a product to powers, distribute to everything on the inside and multiply. So like you can see here, like that, 4 to the second is 16, and then 2 times 3 is 6. Negative exponent rule, we just talked about that. A to the negative m goes down to the bottom as a to the positive m, just like that. Negative exponent part 2, like we said, if it's at the bottom, it can now move to the top and become positive, like that. Anything to the power of 0 is 1, no matter what. And then I put quotient rule 2 because the same thing applies with product rule 2, is that it distributes whatever your quotient is, and if you have a quotient to a power, it distributes to everything on the inside. For example, look how crazy this one is. I like this example, so we'll slow it down a bit. 2 to the 2, 3 to the 2, 6 to the third to the 2. Everything gets that that power of 2. So 2 to the 2 is 4. 3 to the 2 is 9. 3 times 2 is 6. 1 times 2 is 2. And then, this is the part I like. And then you can do an extra rule here. Like, so combine your rules. So now you subtract these, and you're left with x to the 6 minus 2 is 4. So that's a lot of rules now to have in your tool bags, and it's going to take a little bit of time to get. So that's the end of the reference. I'll show you one more page of reference that kind of help you go through it. Again, product rule, multiplying the same bases, add the numbers. Quotient rule, dividing the same bases, subtract numbers. Anything to the power of 0 is 1. Product rule, power rule, power to a power, you multiply. Expanded power rule, look how this one writes it. It just means that everything on the inside gets that power of 3. And same thing with quotients. Everything in that quotient gets the power of 4, whatever you're doing. And then negative exponents, check out, this is like really good examples of all of it. So like you're left with 4 to the negative 2, cross line, change the sign. And then it just goes on from there and there and there. Yeah, so that's kind of where we'll leave off for today. We'll come back to it. I'll give you some practice to go along with this video reference, and we will see each other Wednesday at our Hangouts. Have a good Tuesday.